Hello Geometry, and welcome to this week's instruction. So, like last week where we reviewed slopes and slope-intercept form, this week we're applying it. We're looking at how do we use slopes on coordinate grids. And remember, a coordinate grid is like what you're seeing here with what I'm writing on. It really is just a graph. And a coordinate grid is specifically referencing the lattices, the actual lines themselves that make that grid. And so, thinking about that as applications, our first example, our first kind of point here is how do you find parallel and perpendicular lines from points? So remember, parallel is represented by two vertical lines, and perpendicular is represented by an upside down T. And so if we're given a set of points, how do we determine if lines are parallel or perpendicular? Well, let's go and start with 2 points. And those 2 points are point A, which will be 4, 1, and then point B, which will be -3, 3. So, first things first, we know if lines are parallel if the slopes are the same. And we know lines are perpendicular if there's something called opposite reciprocals. And opposite reciprocals is just the super academic way to say it is going to be the negative version. So if it's already a negative number, it'll be the positive because it's the opposite. So it's going to be the opposite with the fraction flipped. So just applying that to an actual number here. The opposite reciprocal of, I don't know, pick your favorite number. 3/4 is not just 4/3, because we're not just flipping the fraction, but it's going to be -4/3. If you look up reciprocal on Google, just Google search the definition, the mathematical definition they give is that it's being divided. And so the ironic part is when you divide a fraction, you're really flipping it. And so that's why the fraction flips, is because it's representing division. So think about it this way. What's dividing by 2 look like? Well, it's 1/2. So when we want to divide by 1/2, it goes back to being 2 again. And so that's why the reciprocal flips the fraction, because it really means division, and the opposite just means multiplying by -1, changing the sign. So if it was negative, it becomes positive. If it was positive, it becomes negative. So our 2 examples are A and B, 4, 1, -3, 3. So let's apply that now to our examples. So let's go parallel first. We want to determine if lines are parallel. So to determine if lines are parallel, let's pick a point C that ends up at -10, 5. And so we want to know if the line AB is parallel to line CB. Now, how can we determine this? Well, first, we need to know the slope of AB. And so we need to find that slope. And ladies and gentlemen, we can find that slope by using the slope formula, the change in y over the change in x. So the slope of AB, so AB slope, is going to be the change in y's, so 1 minus 3, divided by the change in x's. So then 4 minus -3. And so the slope of AB is -2/7. if our lines are going to be positive, not positive, parallel, if our lines are going to be parallel, then they have to have the same slope. So let's go ahead and find the slope of CB. So CB slope. Let's go ahead and find the change in y's over the change in x's. So the change in y's is 3 minus 5. And the change in x's is negative 3 minus negative 10. And so let's go ahead and work through that. So CB 3 minus 5 is going to be negative 2. And then 3 minus negative 10, that's a lot of negatives. But subtracting a negative is a positive. So we have negative 3 plus 10, which is a positive 7. So ladies and gentlemen, they are the same slopes. So AB and CB are indeed parallel for that reason. In order to be parallel, they have to have the exact same slope. So if this 2/7 had another negative, so if it was positive, it would not be parallel. If the 2 and the 7 were flipped, it would not be parallel, because even though they had similarities, they would not be exactly the same. Now, let's go ahead and find and look at and investigate perpendicular. So I'll go ahead and organize my paper here just by a little bit, box this off over here. Ooh, I want to use black for that. And so that's our parallel work. This is our notes on opposite reciprocals. I'm going to try to stay consistent with my colors here. Let's go ahead and use red to find our perpendicular line. So we want to know if they're going to be perpendicular. We already know the slope of AB. The slope of AB is negative 2/7. So I'm going to rewrite here just to help track that the slope of AB is negative 2/7. But now we need to find the slope of BC. Now I'm going to change the point because we already know that the previous point I used in purple is not going to be perpendicular. It's going to be parallel because it's negative 2/7. So let's go ahead and compare it to a point D. And let's say this point D is at negative 1, 10. So are these going to be perpendicular? Well, in order for us to know, we have to find the slopes. So we want to know the slope of AD. The slope of AD, well, is going to be using, not AD, BD, BD. So the slope of BD is going to be the negative 3, 3 with our negative 1, 10. So first, our y's, the 3 minus 10. The change in y's over the change in x. And so negative 3 for our x minus negative 1. So let's go and do that subtraction. 3 minus 10 is a negative 7. On the bottom, negative 3 minus negative 1. Well, two negatives make a positive. So it's really negative 3 plus 1, which is a negative 2. So far, so good. I see a 7 on top and a 2 on bottom, but we need it to be positive. So ladies and gentlemen, a negative divided by a negative totally gets you a positive. So yes, this example was intentionally planned to model getting to a perpendicular slope because it is the reciprocal, the 7 on top and the 2 on bottom, and the opposite, the sign is changed. So from it being positive, it is negative. So thank you. I look forward to seeing you in the next video.